my name is Matthew Tapenya. Today I'm going to talk about database concept. First, we'll talk about the structure and data dependence problem. First, for the structural dependence. A file system exhibits a structural dependence, which means that access to a file is dependent on its own structure. Next, we'll talk about the data dependence problem. For the data dependence, the data access changes when the data storage characteristic change. Next, we will go to the example. Okay, now for the example, first we'll talk about the structure dependence. For example, adding a customer date of birth field to the customer. Given these changes, none of the previous program will work with the new customer file structure. Next, for data dependence, even changes in the characteristic of data, such as changing a field from integer to decimal, requires changes in all the programs that access the file. Now we move on to data redundancy. In data redundancy exists when the data is stored unnecessarily at different locations. And this will also lead to the file storage difficult to combine the data from multiple sources. Now we will go to one of the examples of data redundancy. First, we have the ERU, which they have the student address and the financial, which also have the student address. This is what we call the data redundancy, because financial doesn't really need the student address, but the ERU needs. But when the student go to ERU to change the address, because the student is moving out to another location, the address here will change, but they didn't go to the financial side to change the address, which will cause the data inconsistency. Now I move on to the data anomalies. Okay, now we're going to talk about the types of data anomaly. First, we'll talk about the update anomalies, which the update anomalies exist when two or more instances of duplicated data is updated.
Hi, my name is Kushman, and now I'll give an example of update anomaly. But first, I'll draw a table that shows when update anomaly exists. So, for this example, update anomaly occurs when the data in the address attribute, only one has been changed and one has not been updated.
Okay, now we're going to the second type of data anomaly, which is insertion anomalies. Insertion anomalies only occur when an attribute cannot be inserted into the database without the presence of other attributes.
So now I'll give an example of insertion anomaly. For example, you can only be a member of a library. You can't enter data in the members table without inserting data in the lending table. So you can only be a member of a library after lending a book.
Next, we'll talk about deletion anomalies. Deletion anomaly exists when certain attributes are lost because of the deletion of other attributes.
So now I'll give an example of deletion anomaly. In this example, the student Alex and Ali have graduated from their university, and the systems want to delete their data from the student name and student ID. But because of deletion anomaly, data 1001, data DS from course ID and course will also be deleted. So now I'll be talking about the DBMS functions. There are several functions that the DBMS can perform to ensure data integrity and data consistency of data in the database. So the first function is called data dictionary management, which is a function to look up the required data component, structures, and relationships. So for the second function is called data storage management, which is a function to use for the storage of data and any related data entry forms that can handle picture and video format. And the third DBMS function is data transformation and presentation, which is a function to transform any data entered into required data structure. The next function is called security management, which is a function that enforces user security and data privacy. The next function is called multi-user access control, which is a function that enables multiple users to access the database simultaneously without affecting the integrity of the database. And another function is called backup and recovery management, which is a function that enables recovery of database after a failure. And the next function is called data integrity management, which is a function to reduce data redundancy and maximize data consistency. Another function is called database access language and application programming interfaces, which consists of a query language which allows the user to specify what must be done without having to specify how. And the most common query language, which is called structured query language, which is also supported by the majority of DBMS vendors. Finally, the last function is called database communication interfaces, which is a function that can accept different end user requests through different network environments. Thank you.
Okay, now I will do the introduction of SQL. What is SQL? SQL is a structured query language. It's a standard computer language for relation database management and also data manipulation. SQL is used to query, insert, update, and modify data of the database. SQL can be divided into three main categories. The first category is data manipulation language, DML. DML is used to add, update, or delete data and is actually a select statement subset, and is comprised of the insert, delete, and update statement as well as control statement. For example, begin transaction, save point, commit, and also rollback. The second category is data definition language, which is DDL. DDL is used to managing the tables and index structures. Example of DDL statements include create, alter, truncate, and also drop. The third category is data control language, which is DCL. DCL is used to assign and revoke database rights and permission. Its main statements are grant and revoke. Now I will write a description of all customers along with the salesman who work for them. Okay, the first line is show that I select the customer name from the customer and the salesman name from the salesman table. The second line is showing that I require the customer table and the salesman table. And the third line is show that I combine the salesman table and the customer table together. So the result is here. You can see that it's showing two columns. One is the customer name from the customer table. One is the name from the salesman table. Here are the salesmen who work with them. Okay, now you write a query to find those customers with their names and those salesmen with their names and city who live in the same city. Okay, the first line is showing that select the customer name from the customer and the salesman name from the salesman and the salesman city from the salesman table. Then the second line is showing that I select it from the salesman table and the customer table. The third line is showing that I combine salesman city and customer city together. So now I will run the query. Okay, we can see that the customer name is listed out in one column and the name from the salesman is listed out in one column, and here's are the common city that live together.
Okay, hi, my name is Wang Jihong. Today I want to teach you how to write SQL query. I will only teach for the question 3, 4, and 5 only. For the first question, write a SQL statement to display all totals ordered by the customers not located in the same cities where their salesmen live. For this question, I just select order number, customer name, order, customer, orders, the salesman ID from salesman, customer, and orders lah. Where customer city is not equal to salesman city. Means it's not located in the same city lah. They're not located in the same city. And we have to link the order table and the customer table together. Okay, we already link the order and the customer table, and we link the order and the salesman table. Okay. Then control enter. Here's the result. Here's the result. Show all the order number where the customer and the salesman is not located in the same city. So now let's proceed to the next question. List all the customer ID, customer name with their order number, purchase amount, order date, that make order in October 2012, and sort the list from highest amount to the lowest. So I have to list customer ID and customer name with their order detail lah. So first select customer ID and customer name, order number, purchase amount, and the order date. From order number, from order and order and customer table. Where the order customer ID equal to customer dot customer ID. This is the statement we link the both tables together, and we need to find the order date within October only, right? So order date between 2012 October for the first day of the October to the last day of the October. And also we need to order from highest amount to the lowest, right? So we have to order by purchase amount descending. This will order the purchase amount from the highest to the lowest. Okay, now control enter. Oh, customer ID in this field is ambiguous. We didn't state which customer ID because both tables also got customer ID. We have to state which customer ID we choose. So now I will choose from orders lah. Okay, control enter. Now, here is the orders that created within the October. Now let's proceed to the next question. Question 5. Show how many customers does the salesman have. So for this question, we have to select salesman ID, then salesman ID, then his name. So count number, account number, count customer ID as number of customer. Rename this to number of customer, then from salesman table and also customer table, where salesman ID equal to customer ID, not customer, salesman ID group by salesman ID. Okay, control enter. We show each salesman have how many customers. Okay, that's all from me. For the next question 6, 7, 8, I will leave it to our next member to solve it. So that's all from me. Thank you.
So hi guys, my name is Lee Chung-un, and I'll continue with the question 6, 7, and 8. So we start with question 6. Show the salesman ID, name, commission rate, who has the highest commission. So the highest commission is also equals to maximum. In this case, we'll use max. Okay, we'll start right now. So we'll start with select as dot salesman ID, name, commission, as commission percent, comma, max, purchase amount, commission, from salesman as unders O, where O dot salesman ID equals as dot salesman ID. Okay. Yeah, so we select what we need to display first, and then we use maximum as commission, and then we took it from salesman and orders. Okay. Yep. Yeah, orders, and then where O.salesman ID equals to S.salesman ID. which is to compare the salesman ID from the both tables. Yep, and then okay, we'll let it run. Yeah, so here it is. Salesman ID 5001, and then the name is James Hop. Commission 0.15 and 864. So question 7 lists down all the customer with their name along with number of orders each of them have made. Okay, so we'll select the customer name, and count customer ID, close it as number of orders. And then from the tables which are orders and customer. Right. Orders dot customer ID equals customer dot customer ID group by customer dot customer ID. Yep, and go. And so here will be the answer. We select what we need to display and then count it, rename it, from which table, compare, and then group by. And this is to avoid repetition of the same name. So the last question. Show all orders with the order number, case, amount, order date, customer ID, and customer name for those customers who carry their grade is 200 or more. Okay. Again, select order number, per case amount, order date, customer ID, and then customer name. From the tables, orders, and customers. Yep. And then where? Orders, customer ID equals to customer customer ID as usual. And then now we use it and customer top 3 more than or equal to 200. Yeah, so we select what we need to display again and then show where is it from the tables, from order table and customer table, and then we need to compare the customer ID, where is it from, and then we only do it customer dot grade more than or equal to 100. Yep. Yeah. So here it is. Okay, and that's it. Thank you.